All right, it's time for 6.7, the energy from biomass notes. And so let's jump into these. And so, one of the first things that you need to understand the difference between is understanding the difference between what is a biomass fuel and what is a biofuel. And so a biomass fuel is something that it comes from organic matter. So that would be wood or charcoal made from wood, or dried animal waste, or dead leaves and brush. So, think of like mulch sort of material, or like an almost like a peat material. And those are burned to just reduce heat. And so biomass is primarily used for heating homes, for cooking. It's one of those subsistence fuels that we tend to use, but we also have trash burning power plants. So it could be, a trash burning power plant as well. And then a biofuel is some sort of a fuel, a liquid fuel that we actually create from a biomass. So it's created from a plant material. So it could be ethanol, which is made from corn. It could be a biodiesel. All right. So some sort of plant oil or sugar that we use to make a biofuel. So it's heavily refined, it's heavily processed essentially to create this liquid fuel. Like ethanol is the most common that I think of. Okay, so that's the difference between biomass and a biomass um, or a biofuel. All right, biofuels can actually be used as replacement fuel sources for gasoline, primarily in vehicles. So, ethanol, using corn to generate ethanol would be, preferential to using oil for sure. All right. So, modern versus fossil carbon, what's the difference between these two? So, burning biomass releases a lot of CO2, but it doesn't increase. The key is it doesn't increase CO2 levels like burning fossil fuels do, because that burning biomass actually releases what we call modern carbon. This is carbon that was recently sequestered from by trees. So trees, plants, animals take in that carbon dioxide and they store it in their bodies. They create biomass. And then we burn that biomass and put that modern carbon back into the atmosphere. Okay. And so that is not necessarily an issue. That's just a natural, more natural part. I mean, it's not natural because it's man generated, but it is a more, it's part of the more, it's less of a problem. I don't want to say natural because it is man-made, but it's just going back into the modern amount of carbon that was already there. And then whereas fossil carbon has been taken out of the atmosphere millions of years ago and stored in reservoirs and sinks, and now we're putting it back into the atmosphere when it hasn't been there for millions of years. That is the problem. And so that when we talk about that carbon dioxide gas that's going back into the atmosphere and increasing the amount of carbon dioxide, remember it's only like 0.7% of our atmosphere. So every little bit of fossil carbon that we put back into the atmosphere becomes a serious issue. And so biomass burning is considered, like when we burn biomass fuels, that's considered carbon neutral, because it's something that was recently calculated as part of that, modern carbon calculation. So think of spending a dollar that someone just gave you versus withdrawing from your long-term savings account. That would kind of be, an equivalence there. And so that is one of the major benefits to using biomass combustion as opposed to fossil fuel combustion. And but there are still some environmental health concerns and some human health concerns associated with burning biomass, however. So biomass does release, when we combust it, it does release carbon monoxide. It releases nitrous oxides, which are those NOxes and SOxes that we'll talk about. Well, not SOx, but NOx that we'll talk about in Unit 7. It does release quite a bit of particulate matter, which can irritate respiratory systems. And then it also releases what we call volatile organic compounds, or VOCs. And so that is a real problem. 3 million people globally cook on open biomass fires in the developing world. So that is a problem in our developing world as opposed to our um, developed world. Biomass burning indoors for heating and cooking actually worsens the effects because now you're trapping the gases and particulate matters inside your home, and that can become, very concentrated inside your house, which worsens asthma. The symptoms of asthma can cause bronchitis for people, COPD, emphysema, eye irritation. All of these things are issues in the developing world that aren't necessarily issues here as much, although still issues. And some environmental consequences beyond just human health concerns would be deforestation. We're cutting down those trees that are actually pooling and sequestering carbon, and then also the air pollutants. So, lack of environmental protection laws and financial resources for other fuels in these developing countries lead to more biomass deforestation in the developing world. And it just kind of perpetuates the problem with their environmental health and their human health concerns. It also creates habitat loss, soil erosion, because we now don't have those trees holding down the soil, loss of carbon dioxide sequestration, and then air and water filtration properties of trees are now lost. So that's all a problem. Again, it can puts NOx into the atmosphere. A lot of these things that impact humans also impact the environment. It puts VOCs in the atmosphere and particulate matter. That all contributes to smog, which we'll talk about more in Unit 7. And then what are biofuels exactly? Just to give you a little bit more information. Basically, it's corn and sugarcane that's fermented over time into ethanol, and it's mixed with some gasoline. So it does still rely on creating ethanol, does still rely on um, fossil fuels, but it cuts down on and allows us to extend our reserves basically of gasoline as much as we can. And so they're broken down, and we allow yeast to ferment the sugars, and this all happens in a production plant. And so E85 or flex fuel is something that we tend to call these different types of fuel, these ethanol fuels. It's basically 51 to 83% ethanol mixed with gasoline. And it's used in flex fuel vehicles. So if you know anyone that has a flex fuel vehicle, we tend to use it for fleet cars a lot. It decreases oil consumption for transport, but it's less efficient than actually just using pure gasoline. So it decreases the efficiency um, of the vehicle itself. It's renewable only to the extent that the production of corn is sustainable. So sugarcane is actually a perennial. Um, and so it's much more sustainable than the corn itself. You only have to plant sugarcane once and it comes back year after year. Corn you have to plant every year. And so, and then we have to worry about the soil fertility and things like that as well. And then there are environmental consequences. So there's a lot of negative consequences, as we've learned about, of having just a monocrop agriculture. It decreases the amount of sort of soil fertility, it creates more soil erosion, et cetera, et cetera. And so there are, environmental consequences of having fields of corn or sugar cane specifically just for ethanol. Um, and so there's also some greenhouse gas that's being released. And so that's an issue. And then, you know, that with crops, growing lots of crops, we have to have a lot of water. And so that can be an issue too when we have a monocrop. And so that is an issue. Also, we have to compete with now, like if we're going to start growing corn for ethanol as opposed to growing it for food, now, you know, we have this competition. We already have a competition with beef. In terms of, you know, growing corn and feeding it to livestock, and now we've got to compete with ethanol fields, and so that's a problem. And then we can't actually use algae to create this oil to create an ethanol. And so that's kind of a promising new field because we can grow algae inside in fish tanks essentially. And it can be used as biofuels way more sustainably than corn. We're not taking up land. And so that would be a really good thing. And so that's something that they're really looking at is using algae to produce that biofuel. Um, and then biodiesel is using liquid fuels that are made from plant oils. This would also be where we would create that biodiesel from the algae. Some of the more common oils that we use are soy oil, canola oil, palm oil. Palm oil has been found to produce 98% more greenhouse gases than fossil fuels, however. And this is due to the clearing of the forest for palm plantations. So that's a real problem. It's contributing to global warming. It's a lot more sustainable if we already have clear land that we're using, or if the plantations are continually replanted. But we also have to consider the environmental impacts of agriculture. So there's lots of like these unintended consequences. You think you're doing something good, and then there's these negative consequences that go along with it. So, clearing the land, we know, releases, you know, lots. There's just all the issues that we learned in Unit 5 that go along with agriculture, those unintended consequences. Okay, so this brings us to our practice FRQ for 6.7. Explain why biodiesel fuels have a different effect on atmospheric carbon levels than fossil fuels do. Remember, think modern carbon versus fossil carbon, and then describe two environmental benefits of using algae for biofuel production rather than corn, palm oil, or sugar cane. All right, and then that's it for the 6.7 notes. Next time we'll be talking about solar energy, and I'll see you guys soon.